Okay, so today we're going to cover section 7 of chapter 10. Today we're going to learn how to write and graph equations of circles. This is going to be the last section in chapter 10, and we're going to end it in a nice, easy fashion. This is an easier lesson. So, first example or first part is the equation when the circle is at the origin, when it's at 0, 0. So when your center is at the ordered pair 0, 0 at the origin, the formula or the equation for the circle is going to be x squared plus y squared equals r squared, where r is the radius of the circle. So for example, in this circle here, if I told you that this radius had a length of 3, my equation for this circle would be x squared plus y squared equals 3 squared. And you're going to have to do the 3 squared. So x squared plus y squared equals 9. Here is an example. Notice the center of my circle is here at the origin. It's at 0, 0. So this tells me the equation I'm going to be using is x squared plus y squared equals r squared. All I need to do is figure out the length of my radius. I have my circle on my coordinate plane, so all I have to do is look for either a horizontal radii or a vertical. So I could just count right here. This is 5 spaces. If you wanted to look at it this way or this way, remember wherever you look for your radii or your radius, it's going to be the same length no matter where it is in the circle. So this radius of this circle is going to be 5. So I'm going to do x squared plus y squared equals 5 squared. X squared plus y squared equals 25. So again, it wants us to write an equation of the circle given the center and the radius. Notice on all 3 examples here, my center is at 0, 0. So again, the formula I'm using to write my equation of the circle is x squared plus y squared equals r squared. So all I really have to do is take each one of these radii and square them. So for part A, I'm going to do x squared plus y squared equals 4 squared. So x squared plus y squared equals 16. For part B, same thing because the center is at 0, 0. X squared plus y squared equals the square root of 5 squared. Remember, when you square something that's got a radical, it just frees up the number under the square root. So part B is just going to be x squared plus y squared equals 5. And lastly, example C, still using x squared plus y squared. This one's a little bit more work because it's 4 times the square root of 3 squared. So for this one, I am doing 4 square root of 3 times 4 square root of 3. Remember, when you multiply numbers that are outside of a radical with a radical, we do the 2 outside numbers together. So 4 times 4 is 16. Then I'm going to do the radical 3 times the radical 3. So that just becomes square root of 9, which is 3. And now I'm going to multiply 16 times 3, and it's 48. So my equation for part C is going to be x squared plus y squared equals 48. So the equation gets a little bit more complicated. However, it's still not that bad. So here, before our center was always at 0, 0, Now our center is going to be represented by the letters H and K. It's still an ordered pair. It's still X, Y, but they're using in the formula the letters H and the letter K. So the standard form of the equation is X minus H and Y minus K, and then you're going to square them and add them and equal it to R squared. And we're going to do some examples of this. So you use this formula when the center is not at the origin. We could use this for the origin also. Let's say we had a center at the origin with a radius length of 3. I could still do x minus 0 squared plus y minus 0 squared equals 3 squared. Notice when you do x minus 0, it just becomes x squared. Same thing here, and then it's 9. So you could still use this standard form of the equation when your center is at 0, 0. Just know when you do x minus 0, just the x remains. Same thing with the y minus 0. But let's go ahead and try some problems where our center is not at the origin. So we have 3 examples again. So again, I'm going to write the formula up at the top. So the formula we're using, the standard form of the equation, is x minus h squared plus y minus k squared equals radius squared. Remember the order pair that they identify for you as the center. This is h, this is k. So now I'm just going to replace the h, the k, and the r, because this is my r, into the formula for each one of the examples. So let's try the first one. X minus the h, which is 1, squared, plus y minus the k squared, and it equals 4 squared. I'm going to evaluate 4 squared, and I'm going to change this 4 squared into a 16. And you're done. All you're doing is replacing those 3 variables, h, k, and r. The only calculation you're doing is the r squared. Now, be careful when your center has an ordered pair that's got a negative number in it. Because if you realize part of your formula up here has subtraction signs, and the negative negative is going to turn it into a positive. So when we go to do part B, again, here is the formula, x minus h squared plus y minus k squared equals r squared. My h, let me write the ordered pair over here. Notice your h is negative 3. So when I go to put it in the formula, I'm doing x minus is part of the formula, and my h value is a negative 3. So realize when you put in a negative number from your center point, this is really going to turn into an x plus 3 squared. So when you have a negative number in your coordinate for your center, it'll end up being a plus sign in the formula. And now the k is positive, so it's just y minus 5. And then the r, again, is the radical. Remember, again, when you square the radical goes away. And this is just a 5. And then part C, we already calculated what 4 square root 3 squared was, but I'll do it again. So it's the same radius as the previous example. So we're going to do x minus 0 squared plus y minus minus, so this will become a plus 2, and then 4 square root 3 squared. So again, 4 square root 3 times 4 square root 3. Remember, you multiply outside and outside, inside and inside a radical. So this becomes 16 times 3, and that's 48. So this x minus 0, I'm just going to turn it into an x squared plus y plus 2 squared equals 48. Pretty good. Nice, easy lesson. All right, let's do another example. We got to calculate the radius from the graph. So again, your center is H and K, and your center here is 4, 1. Your radius length is 1, and then from there you're going to plug it into the formula. X minus H squared plus Y minus K squared equals R squared. And you get x minus 4 squared plus y minus 1 squared equals the radius squared. 1 squared is 1. Okay, so for B, let's label our center. This is H, this is K. I need to count how long my radius is. So it looks like radius goes 1, 2, 3. You could also count it this way, 1, 2, 3. Any place where you could count a radius and count the boxes when it's vertical or horizontal. So the radius is 3, and my H is -5, and my K is 3. So again, let's plug it into the formula. So X, notice the H is negative, so it's like opposite sign, so it's +5. And then Y is 3. So opposite of 3, -3. And my radius is 3. I'm going to square 3, and it's 9. All right, so now this time they're giving us the two equations, and they want us to graph it. So let's take a look at the first one. Remember, in our formula, the center point is right here. Remember, when I pull out to make an ordered pair, it's opposite of what you think. So for this one, what I'm going to pull out for the center is +3, and over here I'm going to pull out a -1. This is my center point. Remember, this is your R, but it's squared. So I would have to square root it, so my R is 2. So I'm going to graph the center point. +3, -1. So my point is right here. And then from there, I'm going to put in the radius. And I'm going to go like north, south, east, and west. So I'm going to go 2 up, 2 to the north, 2 to the east, 2 to the south, 2 to the west. So I'm counting 2 boxes in each direction. And then now what I can do is connect these radii and circle around it. And there's your circle. So you don't need to show those red squiggly lines. The next one, we'll pull the center out. So the center here, opposite of what you think it is, so it's -2. There's nothing being added or subtracted to the y, so that's 0. So my center point is at -2, 0. My radius, again, is still going to be the square root of 4. So the radius for this one is also 2.
Christian Varela, please report.
All right, so now let's go ahead and graph -2, 0. So -2, 0 is the center. And now I'm going to go 2 to the north, 2 to the east, south, west. So 2 up, 2 over here to the right, 2 down, because all of these are the radius lengths. And then just connect them all. And you've just graphed a circle.